As mentioned in the last example, these are type of questions you might see in the SAT and ACT or ACPs. A lot of times they're real-world problems. Let's check one out that's real world. It says advertisements for a new car claim that a tank of gas will take a driver and three passengers about 360 miles. After researching on the internet, you find the function for miles per tank of gasoline for the car is given here, where x is the speed in the miles per hour. What speed optimizes? That means increases to the highest degree. So it's kind of like the max. It'll be like the maximum. The distance the car will travel on a tank of gas. How far will the car travel at that optimum speed? So we want to figure out which speed's the best. So let's go over to our graph and let's type this one in. So I'm going to open up graph and I'll type in the equation. I believe it was 0.25x squared. Let me check real quick. Negative 0.025x squared. Do I have a 0 in there? I don't. So I need to go back here and put in the 0. All right. Now let's let's put the rest of the equation in. Plus 3.5x. And then plus 240. All right, now let's look at this graph. Now I can't see it, so what I'm going to do first is menu, and I'm going to go to Window Zoom, and I'm going to do Zoom Fit. That's something we choose a lot pre-calc. It will zoom the equation out. Now this one doesn't do me much good like that, so I'm going to try again, and this time I'm going to go back to Window and go to Settings, and I'm just going to tell it I'm not concerned with negative speeds, because remember x means speeds, so I'll have, we'll say from -1 to, we can't go negative, but I'll go a maximum of 100 miles an hour. And then for the minimum, the tank of gasoline, we can't have a negative amount of miles per tank. So let's just say -10. And we'll say the maximum is, I don't know, 450 miles. All right. Now here's my graph, and it still doesn't seem to show it. This is leaving room for the car to go a lot faster than 100 miles an hour, and I could change it if I wanted to, but we can see the max. Just in case you doubt, I'll just go to Window and quickly I'll just hit Zoom out, and you'll see, there you go. There's a better idea of how many miles you get per gallon. So if we want to find the optimum speed, we need to analyze graph, and we need to look for the maximum. The maximum occurs somewhere in there, so I want to make sure I'm on the left of it and I'm on the right of it. And it says the optimum speed is 70 miles, which will get me 363 miles driven, 70 miles per hour. I don't think I said miles per hour. That would be its max. So the optimum speed is 70, and which would get us 363 miles. All right, now usually I let you try the next one, but this one's a little bit trickier problem. So on your paper, you might notice you have multiple choice printed off, but I've just covered up mine to give myself some room. So I want to walk you through how you'd solve this one. It says a square with side length x is cut from each corner of a rectangular with dimensions 8 inches by 12 inches. The figure is folded to form an open box as shown in the diagram. Determine the length and width of the box to allow for the maximum volume. So remember, volume is 3 dimensions. And so if you didn't catch what the problem was saying, it says that it is folded. So after you cut these out, imagine those corners falling out. You fold it on these dotted lines. And so when you fold it, we now have a box, because we'll have these, this becomes the floor of the box, and these become the walls. And so we have 3 dimensions. If we wanted to find the volume, we'd have to do the length times the width times the height. Well, the width originally was 12, but it's no longer because we cut out an x here and an x there. So this width has become 12 minus 2x, because again, I cut out one x here, this x distance, and I cut out this x distance. So this is now 12 minus 2x. As for the height, it was 8 inches, but I cut out an x amount here and an x amount there. So it's actually now 8 minus 2x. And finally, since it's volume, it's 3 dimensions. We've got to look at what's the height. Well, this is a height of x, as we've shown earlier. So to find my volume, volume of the box would equal length, which is 12 minus 2x, times height, or I should say length of width rather, which is 8 minus 2x, times the height, which is simply x. We want to determine what value of x maximizes this. So let's go look at the graph. I'm going to go to home screen, get a new document just to clear out the old stuff. And let's go to graphs. So the equation is 12 minus 2x times 8 minus 2x times x. There's our equation. We graph it. I'm going to just zoom out this time for speed's sake. So zoom out. We're looking for the maximum, so I need to be looking up top here. And now let's analyze this graph. Something to point out here when we talk about maximums is some people are going to be thinking, why do I not go to the very top on this side? Well, because you'd be cutting off too much. I'll show you in a second. So this is saying the maximum needs to be 1.57. Okay, I've now made one adjustment to the picture. So this is the maximum is a 1.57. Now, something I want to bring to your attention. You couldn't cut more than 4 inches off. Now think about this. If we cut 4 inches this way and cut 4 inches this way, would we have not cut a total of 8 inches and this entire side length fall off? So our maximum had to be between 0 and 4. That's why it's 0 there, because that's where at 4 inches, 1, 2, 3, 4, the side length would have fallen off. Okay, so that was our maximum right there, 1.57. If I want to find out what the side length is, I would just subtract it. So it'd be 12 minus 2 times 1.57, which would give us a value of 8.86 inches. And then here, I do the same thing. I subtract 2 times 1.57, and that should equal 4.86 inches. And that would be our solutions there.